and take out your textbooks. If you would, turn to page 132. Take out your textbooks, turn to page 132. And I want you to do the review section, numbers 31 through 37. Page 132, do the review, 31 through 37. Take just a couple of minutes to work on this classwork, then we'll go over it together. What are you doing?
Right away, go away.
Are you going to throw it away?
But you did.
Are you going to sit down? Some people, students. (31 through 37) there on page 132. Just another minute or so to be finishing up. Let's go and take a look at these answers together. Go and put your pencils down even if you're not finished. Number 31, we needed to combine a whole bunch of x's together, and there was the random constant term, the positive 7, that had no friends. What did you get for your answer on number 31, Lana?
4x positive 7.
Good, a positive 4x and a positive 7. Excellent. Number 32, we've got some x cubes that need to combine, and we've got some x squares that need to combine. I've mentioned to you before in writing your polynomial answers that if you have a's, b's, c's, and so forth, put your a's first, then whatever b's you have, then whatever c's you have, and so forth, so that the letters from one term to the next progress alphabetically, if there are, especially single letters. But if you're dealing with the same letter, for instance, maybe all you have are a's, but you've got some a squares, and you've got some a cubes, you've got some a's, then you would put them in what's called descending order, where you have the highest power of a, or the highest degree, then the next highest power, then the next highest power, until eventually, for instance, maybe at a constant term, maybe at an 8a cubed minus a squared plus 4a minus, I don't know, 9. Something like that. We could have descending order, and that's what we were looking for here in our answer, is we need to combine our x cubes first, because that's the highest power. What did you get when you combined the x cubes together, Joshua?
Negative 1x cubed.
Good, and then we'll also combine the x squares, and we'll put that next. What did you get when you combined your x squares together?
1x squared.
Good, so our answer was negative 1x cubed, positive 1x squared. Do we have to write the ones? Nah, we could leave those understood if we wanted to. How about number 33? Here we're going for an alphabetical order in our answer. Scott?
5x positive 5y.
Good, a 5x positive 5-way. And then number 34, again, looking for a descending order. So the higher power is m squared. We'll put that first, then we'll follow that with our m to the first power. And Alana, what did you get for 34?
Positive 7m squared plus 1m.
Great job, positive 7m squared, positive 1m. How many perfect on 31 through 34? Maybe you didn't have it in the same order, but you got the same answers.
I didn't finish 34. Number 31 I got.
Okay. Do you understand what you did on 34, or do we need to take, or 31, or do we need to take a look at it?
Take a look.
Now let's go and see here. What I like to do is I like to put in understood positives, and I like to put in understood ones. So you see I've got 2 positive x's and 2 negative x's. Combine the positives to get
8x.
and then combine the negatives to get,
Negative 4x.
and then put those together to get,
Positive 4x.
and then the positive 7 has no friends, so he just is along for the ride. Okay?
Oh.
Does that make sense? That's all we're looking for there. Number 34, you said you didn't finish it?
Yeah.
Right, you see that we've got a 5m squared, and then at the end I've got a positive 2m squared. That's where we get the 7m squared. And of course in the middle we've got the 4m and negative 3m. That's where we get the positive 1m.
I got the 7m squared though.
Okay.
I just didn't finish 34.
Number 35, how many terms, Joshua?
3.
3. Number 36, Scott, how many terms?
1.
1. It's long, but there's still only one term there. There's no pluses or minuses separating terms, or you can think of positives and negatives. And number 37, Lana? 2 terms. Excellent. Any questions at all on the classwork? All right, flip back to page 130, and we begin now getting into a concept that if you can nail it down this year, it's going to make next year in Algebra 1 so much easier. And that's the ability to translate plain English into algebra. Take words and express them as an algebraic expression. The idea behind this is word problems, story problems next year always come back to the ability to translate words into algebra. And knowing what certain words mean is going to help. You see a table here on page 130 of different words that you need to memorize what they mean. Now most of these, it's not going to take a whole lot of work to memorize. For instance, look in the addition column at some of the different things that mean addition. Notice the first word, sum. Well, S-U-M, you should know by now that that's the answer to an addition problem, right? So if it says sum, of course, that would refer to addition. Obviously, if it says added to, you add. We got it? But increased by, well, what does it mean if something increases? It means it goes up or gets bigger, which involves addition, right? So increased by, you might put a little star next to that. More than, well, I think we have that idea. The hard part with more than is, if you remember back to your elementary days, if the question ever said, how many more blah, 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 than blah, 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 then you had to subtract. In translating in algebra, more implies addition, more than, add, and of course plus means add. Put stars next to increased by and more than. Stars next to increased by and more than. What about words that mean subtraction? Go ahead and read that list for us if you would, Scott.
Different, subtracted from, decreased by, less than, minus.
Minus is obvious. Difference, again, you know that's the answer to a subtraction problem. That's obvious. Subtracted from, okay, subtraction is in there. Decreased by. Well, if you're memorizing that increased by means add, then decreased by obviously means subtract. Less than. Well, if you're memorizing more than's add, less than subtract seems to make a lot of sense. Notice the asterisk. Subtracted from, less than. See there it says with less than subtracted from, the result is the second number minus the first number. I had you write this in your books earlier. I want you to write it again. Than, in quotation marks, than, T-H-A-N, means flip the order. than, T-H-A-N, means flip the order. I also want you to write this. The from, F-R-O-M, in quotation marks, the from comes first. Because you're going to sometimes see wording that's even just a little different. It won't use the phrase subtracted from. It might say from this, subtract that. Subtract that from this. Things like that. So the from comes first. If you'll remember that phrase and the than means flip the order, we'll be able to work effectively through subtraction. Why does it matter? Because subtraction's not commutative. Right? Subtraction, Joshua, you can't change up the order to whatever you want it to be. Addition, sure. Any order is fine. Subtraction, no, the order very much matters. I'm going to read our multiplication lineup here. Joshua?
Product multiplied by of times.
All of these make total sense, don't they? Product's the answer to a multiplication problem. Multiplied by. Duh. Of. We've already memorized that of means multiply. That's not new for us. Times. Yeah, we got this. Okay, you don't need to start anything in the multiplication column. How about the division column? Lana?
Quotient divided by per and ratio.
Per is the interesting one there. Per, like miles per hour, something like that. Or gallons per minute, if you're talking about how fast the gas pumps into the gas tank, whatever. Per is interesting. Go ahead and put a star next to that one. Ratio is also interesting, though. If you remember that we write a ratio as a fraction, that is the best way to write it. You could write it with the colon, you could write it with the word two. But if you think of, well, fraction bar means division, ratio is fraction, which means division, then ratio meaning division should not be hard. Obviously divided by it. Quotient is the answer to a division problem, so that one should be pretty straightforward. And then exponents, to the whatevereth power, cubed, squared, multiplied by itself. Put a star next to that one. Because frankly, that's another way of saying squared, right? But rather than saying a number multiplied by itself, it would be easier to say x squared, wouldn't it? That's the more simplistic way to write that. A couple of other things that you see here. Look in the bold section there, or the little bold phrase, the quantity. The quantity is a phrase used to indicate a grouping, so we're going to put things in parentheses. So see how the quantity and right below it is the word parentheses? Underline those and kind of circle that little thing. The quantity means parentheses. So when I say the quantity of x and 5, well, that means we're going to take in the quantity and x and 5. Well, there's another word that's not on the list. What do you suppose and means? This and that. Addition, right? This plus that, right? So you might want to write that down in the space there under addition, or maybe squeeze it in with some, since there's all that extra room around the word some. And is another word that often indicates addition. If you see the phrase a number or some number, that's usually where a variable is going to go. Does that make sense? So if it says a number, since we don't know what it is, we're going to put some variable there. I usually put x, but you can put a, b, Lana could put L, Joshua could put J, Scott, you could put S. Well, I don't like S. And it's not nothing personal, Scott, but if you're not careful, when you write an S, what might you think you're writing? A 5. If you're not careful, the difference can be hard to tell. Now, I will say, for me, I try to put a nice, hard, clear point here at least, so it's easier to tell, okay, S has a curved top, 5 has a flat top. But they can get confusing if you're not careful, especially if your penmanship isn't particularly great. You know what I mean? And they're like, I never have trouble telling my 5s and S's apart. He's like, I know what you mean. Lon, I don't know about the L's, to be honest with you, because if you're not careful, an L can look like a 1. Now, I have this strategy. For me, I always do L's cursive, because otherwise I'll think it's a 1. So if you want to do that, but again, X doesn't look like anything but a multiplication symbol, and that is so last week. We don't use X's for multiplication symbols anyway now. So that's why I like X, but it's your call. There's some other letters that you got to be careful with. Even A, if you're not careful, comes out looking like a Q or a 9, you know? A T can end up looking like an addition symbol unless you put a little hook on it, make it look like, you know, a typed out T has that little hooky thing. It's called a serif, but if you put that little hooky thing on the T, It helps it look a little bit different. So I mean, there's all different letters that are just annoying. X never lets you down. So I'm a big fan of X, but it's up to you, right? A number just means put some variable there. And then it says here, finally, the key word is often indicates equality. In other words, is means equals, but I got something better for you, okay? Because the word is isn't always used. Sometimes grammatically you'd have to say are, because there might be two things. Or just depending on the way the word is phrased, it might use the word am. Or if it was kind of in the past tense, it might say was. In other words, what kind of verbs often pan out being equal signs? Your linking verbs. Oh, no, English class, I know. Write it down. The linking verbs often are, or equal signs. Linking verbs often are equal signs. Now, the good news for you is, this is how Mrs. Henderson's been teaching you linking verbs, right? She says, for instance, Joshua is the leader of the class. Right? She say, find your verb, and you double underline is. Who or what is class? Joshua is who or what class? Leader. Now this is your complement. And then she teaches you, but there's different kinds of complements. And she says, if the complement renames Joshua, it's a predicate nominative. Does leader rename Joshua? Yeah, so leader's predicate nominative. And then she's like, now here's a great way to check if it's really a predicate nominative. If you could say subject equals predicate nominative, right? If you could put equals, Joshua equals leader. Oh, so you've been putting equals in place of a linking verb all along. In general, verbs often indicate equality, right? So when you find that verb in the sentence or the clause, oftentimes that'll be the equal sign, but a lot of times they're linking verbs. So if you remember that linking verbs are oftentimes your equal signs, that will help. Let's look at some examples here. Read the word phrase for us first of all. Lana, they're in the next box.
The ratio of x and 4.
The ratio of x and 4. How do we write a ratio, Lana? Typically as a fraction. So the ratio of x and 4. Or you could remember that ratio implies division, which is shown using a fraction bar, so you put x over 4. How about the next one there, Joshua?
Half of the quantity y increased by 9.
Now, do you see that phrase, the quantity? That means we're going to put something in parentheses. Half of what quantity? What is the quantity we put in parentheses, Joshua?
Y and 9.
Y increased by 9. How do I say y increased by 9?
Y plus 9.
Good. So the quantity y increased by 9 is in parentheses, y plus 9. But it wasn't just the quantity, it was half of the quantity. Well, of means,
Multiply.
and how do I show that 1/2 is being multiplied by y plus 9?
By mushing it right together with the parentheses.
Yeah, just don't put anything in between.
Yeah.
And we got half of the quantity y increased by 9. Make sense? Look at the next one. Read it for us, Scott.
5 times the number squared.
Now it doesn't tell us what number. It just says some number squared. 5 times a number squared. You could pick whatever you want for your number, Scott. M? All right, so the number squared is going to be m squared for you. Could be anything you want it to be. But it's 5 times a number squared. How do I show 5 times m squared, class?
Just 5.
Mush a 5 up against it. 5m squared. Easy enough? Yeah, look at the next one. Lana.
The product of 3 and a number is 12.
The product of 3 and a number. Product means what? Multiply. The product of 3 and a number. What number, Lana? R. So the product of 3 and R means I'm going to multiply 3 and R. How do I multiply 3 and R? So I just write?
3R.
So it says the product of 3 and a number. Then it says is. What does is mean, class?
Equals.
Equals. In general, my linking verbs mean equals. The product of 3 and a number is
12.
So I write 12. And there we go. The product of 3 and a number is 12. And I'm just translating words into an algebraic expression. The last one for us in that box there, Joshua.
8 is 5 less than a number.
All right, it says 8, so I write 8. Then it says is, so class I write
Equals.
equals. Then it says 5 less
Than a number.
than. What does than mean?
Subtract.
Flip it. So my brain is thinking 5 less than, minus 5. 5 less than means something minus 5. Make sense? 5 less than what?
A number.
A number. So
A.
A. Written so it doesn't look like an X. Boom, there we go. Make sense? All right, your turn to try it. Across the page, I want you to do 2 through 12, the even, there on page 131. 2 through 12, the even. Translate these word phrases into algebra. Again, they don't have to have an equal sign. If there's no verb, there's no equals. So if it's a phrase and not a clause, help, then there's not going to be an equal sign in it. This is what happens when the math teacher teaches English in summer school. It's just bad. All right, let's take a look at these. Number 2, how would we write the sum of 2 and x? Good, 2 plus x. Number 4, 3 decreased by c. Joshua?
C minus 3.
Oh, let's skip
3 minus.
3 minus c. There wasn't the word than, nor is there the word from that would tell me I have to consider what might come first. So it's just 3 minus c. Number 6, 12 less than a number. Lana?
X minus 12.
X minus 12, or whatever letter you picked, of course. Number 8, the quotient of d squared and g. D squared over g. Number 10, 4 more than a number is 11.
4 plus n equals 11.
But it had the word than, right? Now
Oh,
technically,
n plus 4 equals.
you're not wrong, Joshua, because addition, you can have either order. But because if we pay attention to it every time we see it, we're not going to have to remember with less than. So that's the only reason I make a big deal about more than. Technically, it doesn't matter. But if I always make a big deal about than, we're not going to forget on less than. So you're not wrong, but better would be n plus 4 equals 11. Number 12, the sum of a number and twice that number is 9. What does sum mean, class? Add. So we're going to add something. It says the sum. So I'm going to add a couple things together, right? Of a number, we could call it
N.
m.
N.
N, okay? The sum of a number, so I put n, and, meaning the other thing that's being added, twice that number.
So
Squares?
Careful, twice doesn't mean squared. What does it mean twice?
2.
2n. All right, so that might be a good thing to jot down. Twice means times 2. Squared means times itself. Twice means times 2. For instance, if Lana has $5, or maybe I give Lana $5, just because I like Lana, and I give Joshua twice as much, because apparently I like him more. Sorry, Lana. Scott, you don't get nothing. I'm just picking on you. I like you too, Scott. But I give Joshua twice as much. Does he get $25? I give her 5, give him twice as much. He gets 25.
No.
No, he gets 10. He gets 2 times as much, right? So when it says twice a number, that means 2 times that number. So the sum plus of a number, n, and twice that number, 2n. But again, once you've picked a variable here, it has to be the same one because it says that number, meaning the same one you had last time. So if you picked A, you better have another A. You picked R, you better have another R. Does that make sense? Now, if it said if the sum of a number and twice another number, then you would have to pick anything other than that. Does that make sense? All right, and then it says is
Equals.
9. And there we go. Did anyone have this, or we all put the squared thing? We got
Yeah,
confused by
that's
that. Does it make sense now? All right, go back and do the odds, 1 through 11. All right, let's see how we did on 1 through 11, the odd. Number 1, 4 times B, Joshua.
4B.
4B. Number 3, S divided by 6, Lana.
S over 6.
S over 6. Number 5, A cubed, Scott. A cubed. And A with a little exponent of 3.
I didn't.
You just skip it?
Yeah.
Okay, I was about to say, how could you have possibly
I
missed
didn't
it?
miss
You
it,
just
I
skipped
just
it. Okay,
skipped it.
that makes me feel a little bit better. I was like, he's paid an A in this class. How did you? Okay, he's just human. He skipped it. Okay, number 7. 7 times the quantity M minus 5. Joshua.
7 in parentheses and minus 5.
Very good. Number 9. Z increased by the ratio of X and Y. Lana.
Z plus X over Y.
Great job. Z plus a fraction X over Y. Excellent. Number 11. The product of 8 and half of a number is 16.
8 and x over 2 equals 16. 8 and x over 2 equals 16.
8 and x over 2 equals 16, like that? Close, but it says in this one, because there's a number in here, we have to set it with parentheses as well. Does that make sense? So normally we wouldn't, but because there are, yeah, or if you slid the 8 to the top and said 8x over 2, I guess that could have worked as well. But yeah, the product, so we're going to multiply two things of 8, okay, and half of a number, let's put the x over 2 in the parentheses, equals 16. That one was a little bit more challenging, because normally we mush them, but there's a number here, a number there. Let's separate with the parentheses. All right, did anyone happen to get number 11?
Wait, so it's X over 2?
Yeah, because half of it, okay, there's another way you could have said it. Half of a number, so the product of 8 and multiplied by it, half of a number could be 1/2 x equals 16, or you could do x over 2, because that means the same thing. Did you happen to have this one here? Anyone have this one?
No, I put 8 times a half equals 16.
Okay, so you got the product of 8 and a half instead of the product of 8 and half of a number, okay? Does it make sense now? All right, questions on the algebraic representation, as it's called. All right, look across the page again at page 130, and next to where it says evaluation, in parentheses, I want you to write numerical substitution. Numerical substitution. That's really what evaluation is. It's numerical substitution, substitution of numbers. Okay? Numerical substitution, and you're used to this already. You look at an example in the blue box there. This is the kind of thing you did last year and the year before and the year before, right? In converting Fahrenheit and Celsius. If you were told that there was a Celsius temperature of 15 degrees, find the Fahrenheit temperature. Well, you would, listen, plug in the 15 where the C was. That's all evaluation is, plugging in the numbers. So if you would, write this down. The key, plug in the number. Or numbers. The key is plug in the numbers. Generally, you'll want to plug in the numbers in parentheses, and you see that picture there, right? They plug the 15 in parentheses, and they just do the math, right? The 15, 5 cancel, give you 3 times 9 is 27, plus 32 is 59 degrees Fahrenheit, which we feel great right about now. We had that a week ago. It's nice. If you use tomorrow, it's not going to be that nice. But yeah, numerical substitution, you're literally just plugging in numbers. So look at the example at the top of the next page. It says x cubed plus x over y minus z. X is 3, y is 4, z is 2. Watch what they did. In for the x, they plugged in a 3. In for the other x, they plugged in a 3. In for the y, they plugged in a 4. In for the z, they plugged in a 2. You substitute in or plug in the numbers. And then from there, you're just following order of operations. Raise to the power to get 27. Then add the 3 to get 30. 4 minus 2 is just 2. So you get 15. Easy enough. Look at the next example. Negative x cubed, positive 7, x is negative 2. Now in for the x goes the negative 2. So it's negative negative 2 cubed plus 7. They cube the negative 2 to get negative 8. But it's a negative times negative 8, which gives you a positive 8. Positive 7 is 15. Do we see what happened there? All right. They start by just plugging in the numbers, and then you follow order of operations. So I want you to now do, we're going to start with some simple ones. I want you to do 13 through 21, the odd. And we're going to start with ones where there's only one, maybe 2 letters involved. 1 or 2 letters involved. Then we'll get to ones where they're a little bit more involved. But 13 through 21, the odd. Particularly if they give you a negative, be careful with those signed numbers. finished. All right, for sake of time, pencils down, even if you're not finished. Let's take a look at these. All I did is I copied them on the board, hopefully correctly, unlike yesterday. And the first thing I did, I just plugged in the numbers. Instead of an X, 8. Instead of M's, 4s. Instead of X's, 8s. Instead of an A, 12, and instead of B's, 5s. Instead of an R, 2, and instead of S, -2. That's all you do in your first step. Now normally you do these one at a time, but you get the idea. From there, it's order of operations. You multiply first class,
56.
and then you finish with the addition. 60. Super easy. Look at the next one. You raise to a power first. 16. And now it's all addition and subtraction. 14. And there we go. Right? You got positive 20, put the -6 with it, you get negative or positive 14. Here, it's addition in the top and subtraction in the bottom, or you can think of positive 8, positive 8.
16.
Positive 16 in the top and positive 8, -6.
2.
Positive 2 in the bottom, or 8 plus 8 and 8 minus 6 means the same thing, which when you divide a positive by a positive gives you a positive 8, or just 8. Looking at the next one. Here I've got a little bit of multiplication here. I'm going to start with this one. 5 times 12
60.
times 3,
180.
180. A little easier than 36 times 5, I think, doesn't really matter. And here I've got a 5 times a 10, 50. So it's either 180 minus 50, or you can think of it as 5 times -10, which will give you -50. So you're either thinking of positive 180, -50, or 180 minus 50. Doesn't matter. Either way, you get what?
130.
130. Looking over here, I've got to square a 2.
4.
You got to square a -2. -2, an even power, still positive. 4. Because remember, when you square a negative, it means you got 2 of them, right? An even number of negatives gives you a positive. And then right here, I've got a 2 times a -2. Well, initially, 2 times -2 is -4. But here in just a minute, it's about to tell me to subtract. And do we ever really subtract, class? No, we add the inverse. So we end up changing it to a positive 4. So 4 times 4, we do our multiplication first.
16.
16. And then we change this to plus a positive 4, so we get 20 for our answer. Do you see how whether you think of it as adding or positive, it's the same way either way? Whether you think of it as negative or subtracting, it doesn't matter. It's going to give you the same answer either way. Does that make sense? How do we do on these 5 problems? Anyone perfect on all the ones you got done? All right, how many of you 4 for 5? Just missed one? Okay. The one that you each missed, do you understand it now?
Sort of.
Sort of. Which one is, I'm guessing the last one. It looks like you're looking over here at the last one. Is it right here with the squaring the negative thing, or is it the, where is it that you struggled? Was it just the whole thing?
It's just the negatives. Like, how is it? Oh, the exponent means that it's positive?
Well, yeah, because if you have a -5 to say the 4th power, Joshua, since this means -5 times -5 times -5 times -5, that means you have 4 negatives, which is an even number of them. And anytime you have an even number of negatives, you get a positive. And then 5 times 5 times 5, okay, that's 625, whatever.
Yeah.
But if you'd had like a -5 cubed, because that means you have an odd number of them, now my answer is a negative. And 5 times 5 times 5, 125. So, yeah, it's just the exponent tells you how many negatives you're going to have. And so that's how you determine whether you get a positive or a negative here. I got a positive because I was having an even number of those negatives.
And then what about, oh wait, you changed the addition to,
Well, this was subtraction, right? It was subtracting a -4 because the signs are different, right? The signs are different, you get a negative.
Yeah.
So it's subtracting a -4, but I changed it to adding a +4 because we never subtract, we add the inverse.
Oh, okay, now I get it.
All right, let's go back into the evens now. 14 through 20, the even. Plug it in, follow order of operations. Be careful with negatives that you have to plug in. last another minute or so to be finishing, then we'll take a look at these together. If you finish early, you can check your answers. Pencils down. Even if you're not finished, let's take a look at these together. On the first one, you were told that x was -3, so plug in two -3s with the sound effects, very important. -3 times 11, -33. -3 times 12, -36. But you're subtracting a -36, so it really becomes -33 plus a positive 36. Or, if you think of this as a -12, you've got a -33 and a positive 36. It's up to you which way you want to think of it. Nothing wrong with either way. Either way, you get to this point, signs are different, you get a 3 and you keep the positive. But there's a faster way. Do you see that these are like terms? They could be combined to get a -1x. You plug in the -3, negative times negative is +3. And it's even quicker and easier when you combine like terms first. Love shortcuts. Love shortcuts. Because I am lazy. The smarter you are, the more you learn, the more you know, the more shortcuts you can take, the lazier you can be. Mathematicians strive for laziness, and in so doing, become incredibly smart people. Anyway, looking at the next one. -v squared positive 5. Keep in mind the v is being squared here, so not the negative. So we've got a -7 squared. Or you could say this is a -1v squared, which means -1 times -7 squared, or -1 times a positive 49. Well, in that case, that's a -49. And of course, this random positive 5 just keeps floating its way down here. We end up with a -44. How do we do on this one?
I forgot positive 54.
Ah, okay. Oh, because did you try to cancel these two negatives here, maybe?
No, like I put -7 squared plus 5 at the beginning.
Oh, this little negative sort of disappeared. You plugged in the -7, but this negative didn't stick around. Gotcha. Okay, does it make sense? Just be careful to copy it down. Kind of like the example problem in the book, the second example higher up on that page, Lana, where it was a -x cubed. Then they had like a -2 cubed. Well, ignore the negative for a minute. -2 cubed is -8. But this negative is still there. Negative times negative gives you a +8. Kind of the same thing that happened here. The next one was easier. You got a 7 times a 6, you got a 5 times a -9, that gives you a +42, it gives you a -45, that gives you a -3. What do we do on this one, number 18? You go there. And then on the last one, the decimal makes this one a little obnoxious because you have to multiply a -5.2 times a 6, comes out to a -31.2. And then we have to subtract a 5 squared, which is subtracting a 25. But instead of subtracting a 25, we could think of adding a -25, which is -25, or -25. Doesn't matter which way you thought of it. We have two negatives, end up with a -56.2 for the
How
end.
did you get -56? I got -6.
Okay, these are both negative, right? This is negative, this is negative. If the signs are the same, add and keep the sign, right?
I subtracted.
But the signs are the same. If the signs are different, like right, Lana, like at -3, -7, it's -10, correct? Looking up here, -3, -7, that equals -10, right? The same thing, -31.2, -25, -56.2. Same type of thing here. Does that make sense? All right, you're going to practice with just a few of these in your homework tonight. For homework, do page 132, the homework section, 1 through 27. Page 132, do the homework section, that's 1 through 27. There is a test coming up in lesson 56, and that'll be on Tuesday. That's coming up on Tuesday. That's lesson 56. Be over chapter 3. All right, you are dismissed. Have a wonderful rest of your day.